Hello everyone. In this video, my friends and I are going to present on the topic prediction of heart disease using KNN. Abstract. Heart disease is a common and potential fatal illness that needs to be predicted accurately and treated early. In this research study, we propose the utilization of K-nearest neighbors algorithm prognostication of heart disease. To acknowledge the challenges associated with the prediction of heart disease, we employ feature selection techniques to detect the most accurate predictors. Additionally, we handle the issues of imbalanced data by employing appropriate sampling or weighing strategies. The KNN algorithm is implemented with various parameter settings, including the value of k, that is the number of neighbors, and distance matrix to optimize the performance of KNN model. Area under the receiver operating characteristic curve, sensitivity, accuracy, and specificity of the model have all been evaluated with cross-validation procedure. Introduction. Heart disease is one of the biggest killers in the world, and controlling its effect on your health and stopping its progression depend greatly on early detection. One well-known machine learning technique used for prediction tasks, such as the prediction of heart disease, is the k-nearest neighbors algorithm. Similarity is the foundation upon which KNN, a supervised learning algorithm, operates. Our application includes developed machine learning algorithms for analyzing various factors and indicators associated with heart disease. It will also highlight the crucial factors aiding to your risk, allowing you to take preventive steps for improving your heart health.
Objectives. The objectives of using the KNN algorithm in heart disease prognostication are as follows. Classification. The chief objective of the KNN algorithm is to classify patients into various categories, such as if cardiac disease is present or not. Prediction. Depending on the input features, KNN is also used to estimate the probability or chance that a person has cardiac disease. Accuracy. This KNN algorithm aims to obtain high accuracy in predicting heart disease. The aim is to reduce false positives and false negatives, ensuring reliable predictions. Early detection. Another objective of using KNN in prognosticating the heart disease is to aid in early detection. This enables quick interventions and preventive steps to reduce the severity of the condition. Proposed methodology. The method which is proposed in this research is KNN. The KNN method is a popular and adaptable machine learning technique that is mostly used due to simplicity and ease of implementation. No presumptions on the underlying data distribution are necessary. It is an adaptable option for a variety of dataset types in regression and classification applications because it can handle both numerical and categorical data. The sensitivity of KNN to outliers is lower than that of the other methods. Using a distance metric such as Euclidean distance, the KNN algorithm locates the k nearest neighbors of a given data point. This approach is based on the Euclidean distance theory, which states that examples with comparable characteristics tend to appear closer together within a data set.
KNN algorithm, K-nearest neighbors. Regression and classification tasks are the two uses for the supervised learning algorithm KNN. That is built on the idea that the similar data point tend to have similar labels. KNN, a non-parametric method, meaning it doesn't assume any kind of specific functional form for the data. Unlike some other algorithms, KNN memorizes the training set during training and performs most of its computation during classification. The key steps of KNN are: choose a value for k, determine the distance, that is example Euclidean distance, between the new data points and all the period data points. Select the k nearest neighbors based on small distances. Assigns new data points to every class that appears most commonly amongst the k neighbor values. KNN algorithm. Working of KNN algorithm. Given a new data point KNN, find the nearest k find the k nearest neighbors based on distance, determines the majority class among those neighbors, give that class ownership of the new data piece. The preference of k is crucial. Odd value of k are preferred to avoid ties during voting. Too small of k may lead to overfitting, while too large of k may introduce noise. Pros. It is easy to implement. It is effective against noisy data, works well with large data sets, can handle arbitrary decision boundaries. Cons. Computationally expensive during classification, sensitive to choose of k, requires careful reprocessing, that is scaling features, handling missing data.
And now we will see the results. KNN or K nearest neighbors uses the Euclidean distance to figure out who is K nearest. Using this algorithm, it is quite easy to detect the disease from the given dataset. Histogram visualization of dataset. Histogram visualization is a powerful technique for understanding, analyzing, and interpreting the datasets across different domains, building it as an essential tool in data analysis and decision-making processes. From the figure, we can observe the histogram visualization of the dataset, where it creates a histogram for each numerical column in the data frame, showing the allocation of values within each column. Affected individuals with heart disease. The individuals who are prone to any of the heart disease are 303 from the given dataset. As seen from the figure, 1 represents male and 0 represents female. The male individuals are diagnosed majorly with more heart diseases, which is caused due to elevated level of cholesterol and high rest BPS, that is resting blood pressure. The females too are diagnosed with the heart disease, but not as much as that of men. Finding the scores of k neighbors classifier for different values of k. To find k neighbors classifiers scores with different k values, use the Euclidean distance formula, that is d of x comma y is equal to square root of summation of xi minus yi into n square, where I is equal to 1. The given formula gives the accurate scores of k neighbors classifiers with different values of k. From the figure, we can find out scores of the k neighbors classifiers. Confusion matrix. Confusion matrix classifies the values which are predicted correctly and which are predicted incorrectly by the algorithm or the classifier. True positive and true negative respectively are symbolized by the green squares, and false positive and false negative on the other hand are illustrated by the red squares. The sum of Tp and Tn gives the value of correctly predicted by the KNN, and the sum of Fp and Fn gives the value of incorrectly predicted by the KNN. The correctly predicted heart diseases by the KNN classifier is accuracy is equal to 83%. Conclusion. The KNN algorithm serves as a key tool in heart disease recognition, offering a non-linear approach to classification based on patient data. By considering the proximity of data points in a multidimensional feature space, KNN effectively discerns patterns indicative of heart-related risk. Through its adaptability and simplicity, KNN provides researchers with a robust framework aiding in risk assessment, early detection, and personalized treatment strategies. As AI continues to progress, integrating KNN algorithms with sophisticated medical datasets, which holds potential in enhancing diagnostic accuracy, improving outcomes for patients, and ultimately mitigating the cost of cardiac disease on global health. Thank you.